Wallet-aware assistants help users ask practical questions about balances, recent activity, portfolio value, and risk. They read on-chain data and turn it into clear answers without moving funds. That makes them a foundation for safer, smarter Web3 experiences. So far, you've seen how agents plan, use tools, and remember, and how blockchains expose wallets, transactions, and contracts. Now we bring those ideas together. An agent can safely inspect wallet state, explain balances and activity, and flag basic portfolio risks. A wallet-aware assistant is more than a chatbot that knows crypto terms. It works as an interpreter between raw blockchain records and human questions. It reads wallet state from chains, indexers, APIs, or SDKs, including balances, tokens, NFTs, transactions, and contract activity. Then it turns that data into plain explanations, such as what the user holds or what changed recently. In this section, the assistant stays read-only. Observe, summarize, and explain. When a user asks about a wallet, the assistant first needs a trustworthy identity, such as an address or a connected wallet. From there, tools gather facts from RPC nodes, indexers, token services, and NFT APIs. Because that raw data can be messy, the system converts it into a consistent wallet state before the language model reasons over it. The model can then add context, assumptions, and limits. Keeping data collection separate from interpretation makes responses more useful, auditable, and resistant to hallucination. A wallet state model turns scattered blockchain records into data an agent can reason about. It should capture native balances, token holdings, NFTs, and recent transactions, along with metadata such as contract addresses, chains, decimals, timestamps, counterparties, status, and estimated value. The key design choice is separation. Keep raw one-chain facts distinct from interpreted labels like high-value asset or failed purchase. That makes explanations more consistent, traceable, and easier to audit. Not every wallet asset should be explained the same way. Native tokens matter because they pay gas and move value on that chain. Stablecoins often represent dollar-denominated liquidity, but still depend on issuer and chain context. Other fungible tokens may reflect governance, rewards, memes, or project utility. NFTs require a different lens, including metadata, collection reputation, and valuation uncertainty. Unknown assets should be handled cautiously, not presented as trusted value. Smart contracts return balances as raw integers, not user-ready amounts. The assistant needs to read the token's decimals and convert that raw value into normal units. Then it adds metadata, such as symbol and contract address, so the user knows exactly which asset is being shown. If a dollar value is helpful, the assistant can estimate it using pricing APIs or liquidity data. When price or metadata is missing, it should say so clearly instead of implying certainty. Transaction history begins as noisy technical evidence. The assistant may fetch it from RPC nodes, explorers, or indexed APIs, then decode function calls and event logs to understand what happened. Next comes classification: incoming value, outgoing value, self-transfer, swap, approval, mint, contract call, or failure. Finally, the result is enriched with token names while preserving the transaction hash, so every summary remains verifiable. Users should not have to inspect every transaction hash themselves. A useful wallet assistant turns activity into a story. Funds came in, funds went out, swaps occurred, gas was unusually high, or some transactions failed. The right level of detail depends on the question. Sometimes a quick weekly summary is enough. Other times the user needs the full breakdown behind it. Wallet monitoring should work like an early warning system, not a judge. The assistant can flag patterns worth reviewing, such as unknown airdrops with no liquidity, broad or unlimited token approvals, sudden transfers to new addresses, or calls to unverified contracts. The wording matters. Phrases like "may be suspicious" or "verify before interacting" keep the assistant helpful without claiming certainty it cannot prove. Wallet Q&A works best when every answer leaves a trail the user can verify. For ownership questions, summarize balances by wallet and chain. For missing funds, clarify the wallet, network, token, and time range before drawing conclusions. For deposits, cite the transaction hash, timestamp, chain, and token contract when available. If data is delayed or conflicting, say that plainly. The goal is not only a helpful answer, but a trustworthy path back to the evidence. Once holdings are normalized, the assistant can translate them into simple risk signals. The goal is not to tell users what to buy or sell. It is to describe what the wallet already shows. High stablecoin exposure may indicate parked capital. Meme coin exposure suggests speculation. Unknown tokens may point to metadata, liquidity, or contract verification issues. Concentration risk shows dependence on one asset or protocol. Strong labels are explainable, cautious, and tied to clear data. Risk labels are most useful when they are reproducible. Start with explicit trigger rules, such as one asset representing more than 70% of estimated wallet value. Then attach confidence based on data quality, token metadata, and price reliability. Keep the facts separate from the interpretation. This wallet is concentrated is not the same as this wallet is unsafe. Finally, show the evidence so users can see why the label was applied and how certain it is. Before deployment, remember that read-only access is still sensitive access. Never ask for seed phrases, private keys, or unnecessary personal details. Store only what you need, and only for as long as needed. Phrase outputs as observations and education, not investment instructions. Verify data sources and flag stale, estimated, or incomplete information. Give users clear consent controls and links to check the underlying transactions themselves. You now have the foundation for wallet-aware agents, retrieving blockchain data, explaining balances clearly, summarizing transaction history, and flagging portfolio risks. The central skill is turning raw on-chain records into useful conversation. Next, we move from reading wallets to enabling safe on-chain payments, authentication, stablecoin workflows, and stronger guardrails.